No, you get credit for it. You worked on it. You get a classwork grade for it. Normally I would take them up for a little quiz grade, but this time, y'all, too many of you weren't here. All right, that wouldn't be fair. All right, so what is a circle? It is a locus, which is collection. Remember, it means collection. It is a collection of points whose distance from a fixed point, that fixed point, by the way, this fixed point is the center of the circle. In the plane is equidistant. Do you know what that distance is? In a circle, what do you call the distance from the center to the circle? The radius. Yeah, this distance is the radius. Yes.
I like circles.
Exactly. So let's start with the center of the circle. It's a point that's same distance from every other point. So the center is going to be here at C. A line segment that touches 2 points on the circle is called a chord. In other words, if we have just any random 2 points and we connect them, this is called a chord. You should remember that a little bit from geometry, I hope. If we have the distance all the way around the circle, the perimeter, the what do we call that? Yes. That wasn't the word I was looking for, actually, but yes. The inside the area.
Oh, yeah, sorry.
Outside edge. Yes. No, it was actually, oh yeah, circumference. Yeah. And then all the way across the circle through the center is what? Diameter. So this whole thing, all the way across, is the diameter. But if we only go halfway across, yeah, this would be the radius. Okay. Now, pi, you remember where pi comes into play here? Pi, 3.14, typically what we use. You have a pi button on your calculator. Did you know that? Yes. Make sure you know where the pi button is. Pi button on your calculator is up over the, I think it's the caret button. Yeah, raise it to a power button. All right, pi is defined as, I bet you didn't realize this, circumference divided by the diameter of any circular object. If you take the circumference, you divide it by the diameter, you get the number pi. An arc is a section of the circumference. So if we take a part of the circumference, so the part of the outer edge, this chunk right here would be called an arc. It has an arc length. It's the part of the circumference of a circle. Now, if we take that and we go from the center to the edges of each of those arcs, this, of course, would be the radius, wouldn't it? Then this inner section right here, this inner chunk, let me go ahead and, in blue right here, this is called a sector. It is part of the area. So the arc is part of the circumference, and the sector is part of the area. So it's like a slice of the pie. Now, the only other thing we need to talk about here before we get into other stuff is tangent. If we have a radius, if we draw the radius right here, this is, of course, R. If we have a line that is perpendicular to that radius and touches the edge of the circle at one point, do you remember what that line is called?
Tangent.
Yes. It is the tangent to the circle. It is perpendicular to the radius and it touches the circle at exactly 1 point. Think about it. If it weren't perpendicular to the radius, then it would touch it at more than 1 point, wouldn't it? It's just barely touching and clipping across, okay? So these are the pieces that we know of a circle. Let's look. We said the arc length was this. Here's my arc length. All the way around, this is 360 degrees, isn't it? So this is going to be a ratio of that. If this angle were 60, 60 out of 360 is just 1/6, isn't it? So this arc is 1/6 of the entire circumference. That's where that theta over 360 comes from. Whatever the angle is here, it's called the inscribed angle. Whatever this angle is, tells you the percentage of this whole circle. Same thing goes for the area. Notice we started the area as theta over 360 times the area. So this sector is just going to be a percentage of the entire area. What percentage it is how much is this angle compared to 360 degrees, the whole thing. Does that make sense? Okay, so when you look at those formulas, please understand. Now let's get into the Pythagorean relationships in a circle. We get the radius is equal to, the radius is the distance from the center to the edge of the circle. Center to the edge. So here's my center. Here's some point XY on the perimeter of this circle, okay? And this is the distance formula. Do you remember that this is the distance formula? We used this last time. Distance formula comes from the Pythagorean theorem, doesn't it? Do y'all understand why the distance formula comes from the Pythagorean theorem? I want to show you something. If I were to take this and go across, and this and go this way, this is the length h, and this is the length k, isn't it? Actually, this is x minus h, and this is y minus k, correct? And you see that it forms what? A right triangle, doesn't it? Which a squared plus b squared equals c squared. So this length of the radius squared is equal to that difference between x and h and this difference between y and k squared. That's where this formula comes from. So the standard form for a circle whose center is at 0, if we called this 0, 0, so if we call this 0, 0 here, and we plug this into this formula, we get the following. And I'm going to show you how. We get r equals the square root of x minus 0 squared plus y minus 0 squared. Difference in the x is x minus x, y minus y squared. So how do we get rid of a square root? We square both sides, don't we? So this goes away. So now we've got our r squared, don't we? And x minus 0 is the same as what? X. So we end up with, think about it, guys. We end up with x squared, boom, y squared, boom, equals r squared. So if the center is at 0, x squared plus y squared equals 0. Now, what happens if the center isn't at 0? What happens if the center is shifted? How do we shift the x?
By putting the number of zeros.
Which letter do we use to show the shift left and right? H. Which letter do we use to show the shift up and down? K. So do you understand that this becomes x minus h squared plus equals r squared? So now, these are even easier to graph than parabolas because all we have to know is the center and how long the radius is, don't we? And then we can just draw in the circle. Area, what's the area formula for a circle? A equals what? That's the circumference. Circumference is 2 pi r. Area is pi r squared. Diameter is equal to twice the radius, right? Length of an arc. If your angle is in degrees, the length of the arc, which we call L for arc length, is your angle in degrees times pi over 180 times the radius. In other words, we're going to convert it into radians. The area of a sector is the same thing. Big S is the area of a sector. We're going to do theta divided by 360. And guys, just so I can point something out for you, I want to rewrite this a little differently. I want to do theta over 360 times 2 pi r. Do you see how this relates to the pictures that we drew previously? We said that the arc length was just a chunk of the outer edge of the circle, didn't we? So I want you to think about it. I want you to look at what that picture looked like. It was on the previous and that's what those formulas are telling you. Okay? It is a ratio of 360, how much of the circle times the circumference, or a ratio out of how much of the area. Okay? All right. You just plug in the formulas and it works. How do we write the equation of a circle? Easy. We plug in H, K, and R. Make sense? Yes? So how do we find H and K?
First one's H and second one's K.
For what part of the circle? The center. Remember, the center is HK. So what is H and what is K for this one?
5 and negative 2.
Yeah. H is 5, K is negative 2, isn't it? Because there's my center. The other thing we need for our formula is R. What is R? Yeah, R is 6 right here, isn't it? So now all we have to do is plug into our formula. Formula is x minus h squared plus, you'll like these because there's not two formulas, it's just the circle formula. We don't have to worry about left, right, up, down, do we? Circles are just circles. So we're going to plug in h and k and r into that. Can you plug in h and k and r?
Yes.
I have confidence in you. Do that now. Take your H and plug it in, take your K and plug it in, take your R and plug it in. Do you notice the convention for H and K changing signs is the same as it was for parabola? If they're positive on the outside, they are negative on the inside. And if they're negative on the outside, they are. All right, so do it. Yeah.
Do you want us to put R as
I want you to
squared,
put,
or do you want us
no,
to
I want you to
do
square it.
layout? Okay.
That's what I thought this stuff.
Good. Easy, isn't it?
Yes. I have a serious question.
Oh, that's why I got food.
But don't be mad. Does the back of your car have an I love physics?
Uh-huh.
I've seen it before too. I'm like, is that Mr. Duffy?
Oh, you know it is. That's because all those cars look the same. Every black car that's that size looks exactly the same in a parking lot. I have a Kia Sorento. But anything that's mid-size like that, that's black, that's like a little SUV like that, they all look the same. It doesn't matter what brand it is. They all look the same. The Nissans look like the Kias, look like the Fords, look like the Toyotas. and you're in a parking lot and black is a popular color for it, which I didn't really want, but that was what I could get at the time. You can't tell which one's your car. You end up wandering around going, where did I park my car? Oh my God, there's 15 cars in this parking lot that all look the same as my car. So when I got a free I Heart Physics from Pasco's bumper sticker, I was like, oh yeah, I will always be able to find my car. Now the only problem is every student who knows me here at the school also knows what my car is now. So I don't know if it's a good thing or bad thing.
Didn't help that you're also telling us, but.
Nah. I mean, it's not hard to figure out. All the staff always knows which one's my car too. They're like, I know which one's your car in the parking lot. I was like, yeah.
I had a bow.
Bow would be cute. All right. What's the equation of a circle with a radius of 5 and the center located on the x-axis where x equals -3? So this is written it a little differently. So the first thing we need to know is where is the center? If it's on the x-axis, where x is equal to -3, what's the x-coordinate? Thank you, Amy. -3. Didn't it tell me that? If it is on the x-axis, what is the y-coordinate? Thank you. What is the radius? Please write the equation. Plug in. You know the basic formula, it doesn't change. Basic formula for a circle is the formula for a circle. It's written right above there if you don't know. And please do not leave a -0 inside a parentheses somewhere. You've got to simplify it, okay? And check your answer, please. Is anybody curious where the y -0 went? Did you leave yours as y -0? Don't do that. If it's -0, just drop the -0, right? Because y -0 is just y. This is my h, and this is my k, isn't it? Notice when the h went in, it became a +3. And when the k went in as 0, it just disappeared. Okay? Now, using translations to write an equation. It says, write the equation for the translation of x squared plus y squared equals 4 by 3 units right and 2 units down. What is the center of this guy? X squared plus y squared equals 4. Is there a number next to the x? So what is that number? Yes. Is there a number next to the y? 0. So the center is 0, 0 right now, isn't it? However, it is going to move that 3 units right and 2 units down. What is the 3 units to the right gonna do to my x-coordinate? It is going to move it 3, isn't it? It's going to add 3. Think about it. If it's at 0, now it's gone 3 spaces this way, hasn't it? Isn't that +3 to the x? What is the 2 units down gonna do? -2 to which one? So now where is the center? Yes. So now I know my HK. I don't even need to list R. R is 5, but I don't need to know that, do I? Because what goes back in the formula is R squared, isn't it? So now I am going to take this R squared and plug it there. And I'm going to take this HK and plug it back in here. So I just have to plug back into the formula, don't I? So the generic formula for this circle is going to be x minus 2, y minus 1 equals what? Which is? And we've now written the equation from a point and a circle. Yeah, it's easy. Easy, easy. All right, write the equation of a line tangent to the circle. This one's a little tougher. It's now given, write the equation of a line tangent to the circle. Remember that tangent to the circle at 6, 4 means at this point 6, 4, the circle is going through and the line is perpendicular to what? It's perpendicular to the radius there, isn't it? So guess what? I need to find the slope of the radius at that point. So step 1 says find the slope. In other words, from the point 2, 1 to the point 6, 4. Do you remember how to find the slope? Slope formula, just as a reminder, slope formula is y sub 2 minus y sub 1 equals x sub 2 minus x sub 1, isn't it? So that would be, here's my y sub 2, right? And here's my y sub 1. So this would be 4 minus 1, x sub 2, x sub 1. So this would be 6 minus 2. So this is going to be 3 over 4, isn't it? But that's for the radius. We need the one perpendicular to it, which is the tangent line, isn't it? Do you remember how to find the slope of the tangent, or slope perpendicular? Flip and change the sign, right? So M perpendicular is going to be, if it's 3 over 4, flip it over. Becomes what? And change the sign, right? So it becomes negative 4 over 3. Does everybody see? Flip and change sign. Right? And then guess what we're going to do? We're going to plug into the point slope formula. If you don't remember the point slope formula is y minus y sub 1 equals m times x minus x sub 1. We have m, and we have x sub 1, y sub 1, don't we? M is going to be this guy right here. X sub 1, y sub 1 comes from the tangent line of the circle. That comes, it said it was tangent at that point, didn't it? 6, 4. So that's the point we plug in. So if we plug this in, this becomes y minus what? What was my y coordinate of that point on the circle? 4. So it becomes y minus 4. What is my slope? Yep, negative 4 over 3 goes in. And then it becomes x minus what? Yes. And that would be the formula for that would be the equation of the line. Okay? So we find the slope of the radius with that point. We flip it over and change the sign. And then we take that point and that flipped over slope and we plug it into that formula again. Okay? Completing the square. For some of you, this is going to freak you out. For some of you who were here last time, we're just going to do this not once this time, because what do we have now? We have both an x squared term and a y squared term. So, for those of you who weren't here, let's remember how to complete the square. The first thing we need to do is put the x terms together and the y terms together. So what goes with x squared? We do x squared plus 4x plus blank. And now we're going to put the y squared terms together. So we have plus y squared minus. Now we have one more term that's left over. Y'all remember why I'm putting the plus blanks, right? So this 8 needs to go to the other side. So what does it become on the other side? Now, if I add two things to one side, what do I have to do? Also add them to the other side. So we need to do plus blank and plus blank over here, don't we? We are setting this up to complete the square. Well, this blank right here, that's for those. And then remember, we'll figure out what the blank goes in the blanks. Remember how we complete the square. We take half of the middle term. Remember, square, double, square. So we've already got the square and the double. We just need to figure out what the other square is. This comes from this guy. This is doubled.
2.
Yeah. So if we undouble it, it's 2, isn't it? Right. So we're going to undouble this and then square it to get it here. So half of this is undoubling, isn't it? So we take half the middle term, which is 2, and then we square it to put it here.
Which is also 4.
Yeah. So half of this is 2, square it, we get 4. So that's the first thing we're going to do. I think people don't explain, you don't understand why you do stuff sometimes because people don't explain what you're doing. So we're halving it, we're squaring it, and so we put a 4 here, which means we also need to put a 4 where? On the other side. What you add to one side, you must add to the other. Now we're going to do it again because we've got another square we need to turn. So what is half of this side? We're undoubling -6. What do we get? And then we're going to square it. Now, this guy right here becomes a perfect square. X what?
X plus 2x. Yeah.
X plus 2 squared. Remember the secret I told you, which was whatever is here is what ends up here, sign and all.
So that's x
So now it's plus what?
plus y minus 3 squared.
Equals, and then we just add up what the numbers are on the other side. 4 plus 9 is?
13.
Minus 8?
5.
Yep. So we get this is 5. And look what we have. We now have a circle
Right.
whose center is where?
At -2, 3.
And whose radius is what? Ooh. Nope. You just went the wrong way. That is r squared. Guys, this is r squared. Yeah. Go the other way. That's why I asked that question, because somebody inevitably squares and goes the wrong way. All right. So let's. In college. All right. So is there. Sorry.
Oh, no.
Yes, absolutely. You may. Woo! Now we got challenging circles. What if we're given the diameter? Uh-oh. If we're given the diameter, where is, guys, if I were to graph this circle and say I have 1 point here and 1 point here, let's say this is -3, -1, and this is 5, 5. Diameter goes through what point? Goes through the center, doesn't it? So from here, can we find where the center is? Center is going to be exactly halfway, isn't it? What is that point called? The midpoint. Remember midpoint formula? So this is at the midpoint of the diameter. The midpoint formula says this. You add the x's and you divide by 2. You add the y's and you divide by. Let's find the center of this circle. So we're going to add up the x's. What are the x's? -3 and 5. Doesn't matter what order you put them in. So -3 plus 5 over 2. And we're going to add the y's now, aren't we? So -1 plus 5 over 2. So where is this? Where is the center? This is going to be what? 2 over 2, which is, and this is going to be 4 over 2, which is
2.
So now we know that this is 1, 2. And guess what, guys? We now know the center and another point, don't we? Didn't we just do this problem? So we know the center. We know HK now. What is HK? One, 2. And pick an XY. You know which XY I'll pick? The one that's easiest. Which is the easier XY here? 5, 5, right? And now we're going to plug it into, you see what I mean about, didn't we just do this problem? Because now we need to find the radius, don't we? So this is going to become what? Yep. And this is going to become, okay, so this becomes 4 squared plus, so what is r squared here? He's so funny.
25.
So now we have r squared and we have the center point, so can we write the equation? We're just going to plug back into that formula, aren't we? So my equation becomes x minus what? Plus what? Equals, ta-da! Now it wants you to find the equation of the line tangent to the circle there. Okay, so we have to find the slope from the center to that point, don't we? Do you see we're doing the same problem again, aren't we? What made this one more challenging? It didn't give us the center. We had to go find the center first using the midpoint formula, and then we move on, didn't we? This is just like 5B. And then can we sketch the circle? Yeah, we sure could. And we could sketch the tangent line too, couldn't we? So let's see what. Pretty good. You have homework to do. You have the circle homework to do. Circle homework should be fairly straightforward, easier than the parabola homework. If you did not do the parabola homework because you weren't here, you need to make that up as quickly as possible, okay? You do not want to fall behind in this unit. Because next time, we did parabolas, we did circles. Next time, we're going to do ellipses. Here. Oh, were you not done? Last one is. Uh-oh. You know what? I'm not going to ask you to do anything that hard. That's a nope.
No.
Nobody's ever going to ask you to do that.